Continue on with the notation from the last video and look at how to calculate some probabilities on that normal curve that wouldn't necessarily fit what we saw with the empirical rule back in chapter 3. So here at the top I've got some instructions on how you can find probabilities in your calculator. If you have a normal distribution, you want to hit the second button and then vars, which is over here next to clear. And you're going to pick the second function, which is normal CDF. Normal CDF stands for normal cumulative distribution function. And we're going to input 4 values. The lower bound, where does my shading start? The upper bound, where does my shading end? The mean, and then the standard deviation. We'll hit enter, and the result is the answer. Let's look at several examples using this function. It says women's heights in inches also typically follow a normal, or an approximately normal distribution within 65.3. Recall from last video that this would be my mean, my mu, and this 3 would be my standard deviation, my sigma. We want to find the probability that a randomly selected woman is between 60 and 65.2 inches tall. It always helps me to draw a picture to get an idea of what's happening. It says women's heights follow an approximately normal distribution. Draw out my bell-shaped curve. The mean is 65. That should be toward the middle at that highest peak. And the standard deviation is 3. Just like we did back in chapter 3, I could go up 3 and down 3. This could be 68. This could be 62. I could go up to 71, down to 59. I want the probability that a randomly selected woman is between 60 and 65.2 inches tall. So 60 would be down here, below 62. 65.2 is just above the mean. So I'm looking for this probability or this area. Now note I couldn't use the empirical rule because I didn't go up exactly 1 standard deviation and down exactly 1 or 2 standard deviations. So I can't use that 68, 95, 99.7 rule. I have to use this normal CDF function in my calculator. This is not a traditional shape like a rectangle or a triangle, so I don't have an area formula, and that's why we're going to go to this section of our calculator. So we're going to select normal CDF, and we're going to input 4 values. So again, to get there, you hit the second button, you hit vars, and you want number 2, normal CDF. We are never going to use normal PDF in this course. We're going to use normal CDF, the cumulative distribution. So you can either scroll down and hit enter, or you can just hit the number 2. And I'm going to enter in 4 values. The lower bound, where my shading starts, well, I'm looking at heights between 60 and 65.2. So 60. Then comma to separate the upper bound where my shading stops. That would be 65.2. Comma, my mean I know is 65 from the problem. And my standard deviation is 3. I just hit enter, and there is my result. This is equal to 0.4788 if you round to 4 places. And typically in my stat lab, these problems will ask you to round to 4 places. So it was 60, 65.2, 65, 3 to get that probability. This tells me about 48% of women are between 60 and 65.2 inches tall. Let's look at 2 more examples where we use this normal CDF function. Same information about women's heights from above. I want the probability that a randomly selected woman is taller than 65.5 inches. Women's heights follow a bell-shaped distribution, a normal distribution, with a mean of 65 and a standard deviation of 3. I want the probability that a woman is taller than 65.5 inches tall. So 65.5 would be just slightly above that 65. And so the woman could be taller than that, could be 70 inches tall, 72 inches, 76. And theoretically, the normal distribution goes on forever. I don't know how tall the tallest woman in the world is, so I don't know where to stop for my upper bound. So we'll take into account women that are 10 feet tall, that are 30 feet tall, that are 100 feet tall, even though that doesn't make any sense. Based off of the information that we have, that probability is so slim that it's going to have very little effect on our answer. It's going to have no effect when we're rounding to 4 decimal places. Because I'm looking for a probability using the normal curve, I'm going to use the normal CDF feature. My left bound, my shading starts at this 65.5. My shading goes all the way up the left-hand side, all the way up the right-hand side of the normal distribution, all the way up to infinity. There's no infinity button on the calculator. The highest number your calculator can take is 10 to the 99th. I'm going to put in E99. I'll show you how to do that shortly. The mean was 65, and the standard deviation was 3. Second vars, number 2. 65.5 is my lower bound where the shading started, comma. Now to get up to that E99, to get that E that we've been seeing in the previous chapters and in this chapter as well, you hit second comma. It's that double E, but it's only going to show up as one E. That's the 10 to the certain power. So it's E99, 10 to the 99th power. Then comma 65, comma 3. I hit enter. I get 0.4338, or about 43%. So 43% of women are taller than 65.5 inches tall. That's 5 foot 5.5. One more example going the opposite way, once again talking about women's heights in 65.3. I want the probability. That's a key word that tells me to use normal CDF. When I want a probability and I know I have the normal distribution, which that's what I know about women's heights, I know I'm going to go to normal CDF. I want the probability that a randomly selected woman is shorter than 59 inches tall. So here is my normal curve, 65 in the middle. And by the way, 59 would be considered an outlier. If you go down a standard deviation 3 inches, that would be 62, and a second standard deviation, that would be 59. And once you go down 2 standard deviations or more, you're in that outlier range. 59 would be an outlier. And I want women that are shorter than 59 inches. So I want all of these outliers. What's the probability that a woman's height is that low? So again, probability on the normal distribution, I'm going to use the normal CDF function from my calculator. Second vars, number 2. My shading always goes from left to right. So this is going to go all the way down the curve to 50 inches, to 40 inches, to 30. And it theoretically goes all the way to negative infinity. To input that in my calculator, it is negative E99. So negative button, second comma brings up my E99. Comma, my upper bound, my shading stopped at 59. Then put in my mean and my standard deviation. Hit enter. and this gives me 0.0228. So about 2% of women are outliers on that lower end, are shorter than 59 inches tall. My calculator is in that classic mode, which was one of the first videos you were supposed to watch for this class. So if you select normal CDF and you're getting a menu that says lower, upper, mu, and sigma, you just enter in those values in each place and it copies and pastes them into what you see in my classic mode. Final question to wrap this video up. What is the probability that 2 randomly selected women are shorter than 59 inches? Well, I just found the probability that 1 woman is shorter than 59 inches. So the probability that the first woman is shorter than 59 inches is 0.0228 times the probability that the second woman is also shorter than 59 inches is also 0.228. We're assuming independence, that this woman's height has no effect on this woman's height. This woman doesn't make the second woman taller or shorter. So I can just multiply that out, 0.0228 times 0.0228. I'll just square it. And it's not 5.1984. We've got that scientific notation. It's 0.00052. You would move this decimal 4 places to the left. So 1, 2, 3, 4, and that's why I have 3 zeros there.